Hi guys and welcome again in our very section of discussing trigonometry. Well, in the last lecture, I told you some superbly important points which you are supposed to keep in mind while solving trigonometric equations. Yes, you cannot afford to either lose any root or you cannot afford to either get any extraneous roots. Yes, getting extra roots is also not at all giving you the correct solution set, and losing some of the roots is also not giving you the exact correct solution set. And that is why you need to keep in mind that you cannot, or basically you have to avoid squaring or raising to higher powers both sides of the equation or extending the domain of trigonometric equation in order to avoid extraneous roots. And on the other hand, you have to avoid restriction of the domain of the trigonometric equation or cancelling out like terms from both sides of the trigonometric equation to avoid getting loss of roots. That is when, even if you feel that it is required to square the terms or cancel out like terms, or you are ending up manipulating the entire equation in such a manner that it is leading to either extension of the domain or restriction of the domain, okay, do it. But in the end, kindly check for extraneous or lost roots, because these are the only factors which lead to the creation of such type of roots. So you need to in the end check and then get rid of extraneous roots or involve the lost roots and complete your solution set. Yes. Today what we are going to do is something ahead of all these types of notations, and that is solving inequalities. We will be learning to solve certain inequalities. Now, what type of inequalities we will be dealing with? We will be dealing with something known as trigonometric inequalities. Now, everybody of us is aware about the term inequalities. When I am saying trigonometric inequalities, I am obviously bringing into picture both the notation of inequality and the notation of trigonometry. How am I bringing both these notations together in order to form or give you the idea of trigonometric inequalities? Well, inequalities involving trigonometric functions or ratios, whichever term you feel comfortable in. So what did I write? I wrote those inequalities which concern trigonometric functions or trigonometric ratios are called trigonometric inequalities. We know the inequalities, they are strictly less than, strictly greater than equal to, less than equal to. That means somehow we will be dealing with a picture consisting of all such signs and consisting of trigonometric functions. Yes, an expression which consists of trigonometric functions and such signs is what is called a trigonometric inequality, which makes sense. And that is what we would be learning to deal with. When I am saying we need to deal with trigonometric inequalities, what is it that I wish to tell you? Basically, we will be learning to solve not now the trigonometric equations, but now the trigonometric inequalities with the help of trigonometric equations. Yes. Till now, what we dealt with was we had a left-hand side and a right-hand side being equated by an equal to sign, and on the left and right, we had trigonometric functions and we declared such statements as trigonometric equations. Whereas over here, you will be again having a left-hand side and a right-hand side with trigonometric functions involved, but in between, you will be having not an equality this time, but some inequality. And that is when such an equation will not be, or basically I should not say equation, such an expression will not be called a trigonometric equation. It will be called a trigonometric inequality because there is not an equal to sign in between. Instead, there is an inequality in between. For example, if I am saying 2 times cosine of x is greater than 1 by 3. This is a trigonometric inequality. It has a left hand side, it has a right hand side. To the left, there's trigonometric equation involved. This completely has this strictly greater than inequality in between, and therefore it becomes a trigonometric inequality. Or on the other hand, if I say sin x plus cos x is less than 2. This is again a trigonometric inequality. It has trigonometric functions, it has the inequality sign, it becomes a trigonometric inequality. When I am saying what do I mean by dealing with trigonometric inequalities, I wish to say that we will have to learn to solve trigonometric inequalities. Yes. Just like we learned to solve trigonometric equations, exactly in a similar manner, we have to learn to solve trigonometric inequations or inequalities. Yes, wherever there are no equalities, I am going to term them as inequalities. We have to learn to solve trigonometric inequalities. And what is that one task that we need to do, or the idea we need to keep in mind for solving trigonometric inequalities? That will be portrayed to you by this article, which is solving inequalities. I will be showing to you a certain type of idea which you have to keep in mind for solving trigonometric inequalities. The first thing that you need to understand is, what do I mean when I say that you need to solve trigonometric inequality? Just consider the two examples that we have written over here. Suppose I say that the task is to solve the inequality twice of cos x strictly greater than 1 by 3. Suppose that is what is the task. The task is to solve the very inequality 2 cos x strictly greater than 1 by 3. When I am saying you need to solve this, that means you need to find out the values of the unknown angle theta for which this is satisfied. Yes, exactly the same scenario like we dealt with in trigonometric equations. The exact same scenario comes and lands over here. You need to find the values of such unknown angles represented by the unknown angle x over here. You need to find out all the values of this unknown x, which when you plug in, it gets satisfied. What do I mean by it gets satisfied? Well, the moment you plug in that value of the unknown angle x, over here, you will find out that twice of cos of that angle is definitely coming out to be strictly greater than 1 by 3. And the set of all such values of unknown angle x, which are going to satisfy this trigonometric inequality, will form the solution set of this particular inequality. And that is what is the meaning of obtaining solution to a trigonometric inequality. Exactly in a similar manner, if I say, give me the values of all such unknown angles x over here, such that when I plug in those values in the next inequality, it gets satisfied. That means give me the values of all such angles which on being plugged in on the left hand side of this inequality, that is when you plug in that value of x in sin x plus cos x, you get the answer to be strictly less than 2. Once you collect the values of all such angles which satisfy this inequality, they comprise to be the entire solution set for this inequality. That is the meaning of solution of a trigonometric inequality. The question is how to obtain that solution. How do we proceed to solve an inequality to get in the end the solution of that inequality? And this is the article which is going to share with you the idea of solving the inequality. It says to solve a trigonometric inequality, what do? We obtain the solution of the trigonometric inequality in one period of the trigonometric equation in the trigonometric inequality and after that what we do? And then add numbers of the form 2n pi, where n comes from the collection of all integers. Add numbers of the form 2n pi to each of the solution in that interval. Yes, this is what happens to be the very algorithm to help you obtain the solution of a trigonometric inequality this time. It is saying that trigonometric inequalities are made up of trigonometric functions. Every trigonometric function is periodic, and by the very property of trigonometric functions periodicity, you can successfully find out the entire solution set of trigonometric inequality. What do I mean by this? Well, every trigonometric function is periodic by some period, say t. That means over every interval of length t, the function's behavior, the trigonometric function's behavior is exactly the same. That means, and that is why we are always interested in studying the behavior of the function in one specific period. The moment you are able to get the behavior of the trigonometric function in one specific period, you just repeat that behavior over every interval of length t. And therefore, you get the behavior of the function over the entire domain. That is what you do. Over here also, if you wish to find out the solution set of a trigonometric inequality, what you do is, whichever trigonometric function is involved in the trigonometric inequality, that is going to possess a certain period. What you do is, you from that one period of that trigonometric function involved in the trigonometric inequality, from that one period you select all the solutions of that trigonometric inequality. That means from one period you will be able to know which all are the solutions of that trigonometric inequality. And the moment you obtain the solutions of that trigonometric inequality from one period, after that you add numbers of the form 2n pi for every integer n to each of the solution obtained in that specific interval of length of the period of the trigonometric function. Yes, the entire task dissolves to not finding all the solutions or whacking your brain behind finding each and every solution in the entire domain of the trigonometric function in the trigonometric inequality. No, you just need to focus on a subinterval of length equal to the period of that trigonometric function and find all the solutions lying in that one interval, one specific interval of length equal to the period of the trigonometric function. And once you obtain all the solutions in that one period, what you do is, to each and every solution you add 2n pi. The moment you add 2n pi to each and every solution obtained in that interval of length 1 period of the trigonometric function, you obtain each and every solution spread in the entire domain of the trigonometric function satisfying that inequality. Why? Just because if in one interval there is a point, say x, for which the inequality is satisfied, for which the trigonometric function is behaving in such a manner that the inequality is satisfied, definitely when you add 2n pi to that particular x, again x plus 2n pi, at this point also the function's behavior will be exactly the same, and therefore again the inequality will be satisfied, and that is why x plus 2n pi will also become successfully a solution of the same trigonometric inequality. This is because if you remember, each and every trigonometric function that we've discussed either has period 2 pi or has period pi. So when I'm saying tan, for example, has period pi, the next thing I'm going to say is it has period 2 pi as well. It has period 3 pi as well. It has period 4 pi as well. And that is why this 2n pi serves as giving you the correct answers corresponding to every trigonometric function. Because every trigonometric function definitely has 2n pi as its period. 2 pi, 4 pi, 6 pi, 8 pi, all of these are periods of every trigonometric function. And that is why once you have obtained solutions in one specific interval of length equal to one period of the trigonometric function, adding 2n pi to each member of that solution is going to give you the entire solution set of that trigonometric inequality. That is what happens to be the algorithm to obtain the solutions of a trigonometric inequality. Let's deal with one of the examples and make this concept very clear. For example, I say solve sin x strictly greater than half. Suppose this is what I'm asking you to solve. Again, you can very well see this is nothing but a trigonometric inequality having the sine as a trigonometric function over here. Again, if I am asking you to solve this, that means I am asking you to find each and every value of the unknown angle x, which on getting plugged in inside this particular expression, which is sin x, comes out to be strictly greater than half. Solving sin x greater than half means I am asking you to give me all such unknown angles x, or all the values of this unknown angle x whose sine ratio is greater than half. Yes, that is what I'm asking you to find. Find all the angles whose sine ratio is greater than half, collect all of them, and that is what is your solution set of this trigonometric inequality. In order to solve this, let us first examine the graph of the sine function. How does the graph of the sine function behave? Well, if you remember, this is how the graph of the sine function behaves. Obviously, the maximum that it attains is 1 and the minimum that it attains is -1. the outputs or basically the sine ratios corresponding to any angle on the x-axis always is less than equal to 1 and greater than equal to minus 1. That is something very true about sine function or sine ratio. Now, if the sine ratio is always lying between minus 1 to 1, I am asking you to give me all such angles wherein sine ratio is strictly greater than half. And what is the algorithm? The algorithm is solve the inequality for one specific period of the trigonometric function in the trigonometric inequality. The trigonometric function in the trigonometric inequality is your sine function. What is the period of sine function? It's 2 pi. So, I am going to select one interval of length 2 pi and inside that interval contained in the entire domain of the sine function, I am going to find all the solutions which satisfy this inequality. That means I am going to select one interval of length 2 pi and inside that interval, I am going to find all the angles whose sine ratio is greater than half. Let's do that. The first interval that I select is the interval from 0 to 2 pi, which is my interval of length 2 pi. I am only concerned right now with obtaining solutions from this interval of length 2 pi. That is, I am only concentrating on 0 to 2 pi. And inside this particular subinterval, I am interested in finding all the angles whose sine ratio is greater than half. Observe carefully. At pi, the angle pi lying in the interval 0 to 2 pi, which is the interval of length equal to the period of the trigonometric function sine, at pi the sine ratio is 0. At 2 pi the sine ratio is 0. At all the members between pi and 2 pi, what is the sine ratio? The sine ratio, as you can see, is at any point here, the sine ratio is negative. Similarly, at any point, suppose here, the sine ratio is minus 1, again it's negative. That means at all the angles between pi and 2 pi, the sine ratio is negative. It is lying between 0 and minus 1. But I don't want that. I want those angles whose sine ratio is strictly greater than half. That means angles from pi to 2 pi are of no use to me. Because over here the sine ratio is definitely not greater than half. In fact, it's in negatives. That means in the very portion pi to 2 pi of the interval 0 to 2 pi, I am not getting any solution of the trigonometric inequality sin x greater than half. Let's now focus on 0 to pi portion of this interval. At 0, the very sine ratio is 0. At pi, the sine ratio is again 0, definitely not greater than half. I want the angles which give the sine ratio greater than half. Now you tell me one thing. Over here somewhere will be my half line beneath 1. Which is that angle between 0 to pi wherein the sine ratio is half? Well, I know that unique angle in 0 to pi by 2 subinterval. If I just take that to be pi by 2, suppose this is pi by 2, then that unique angle in 0 to pi by 2 wherein the sine ratio is equal to half is 30 degrees. Yes, sine of 30 degrees or pi by 6 is 1 by 2. This is the angle pi by 6 at which your sine ratio is 1 by 2. And after that, in the interval 0 to pi, one angle I have got where the sine ratio is equal to half. And I know that sine of pi minus theta is same as sine theta, which is again half. And what is sine of pi minus pi by 6? This is nothing but sine of 5 pi by 6. And from pi, if I subtract pi by 6, I get 5 pi by 6, wherein again the sign ratio is equal to half. If at pi by 6 the sign ratio is half, and after that at 5 pi by 6 the sign ratio is half, observe carefully, from 0 to pi by 6 the sign ratio is less than half, and from 5 pi by 6 to pi again the sign ratio is less than half. That means from pi by 6 to 5 pi by 6 you can see that the sign ratio is greater than, strictly greater than half if I exclude pi by 6 and I exclude 5 pi by 6. Because at pi by 6 and at 5 pi by 6 the sign ratio is exactly equal to half. I am not wanting equality. I am wanting strictly greater than, and that means you strictly go ahead of pi by 6 and strictly stay back from 5 pi by 6. In this particular section, from pi by 6 to 5 pi by 6, where pi by 6 and 5 pi by 6 I am excluding, I am getting the sign ratio to be strictly greater than half. That means what? That means when I picked up one interval of length equal to the period of the sine function, that's 2 pi, in the entire interval, the only section of this interval which is delivering me with the values of the angles whose sign ratio is greater than half is the section from pi by 6 to 5 pi by 6. Because apart from these members, if I particularly mark, apart from these members, none of the angles have their sign ratio greater than half. Before pi by 6, sign ratio is less than half. After 5 pi by 6 to pi, sign ratio is again less than half. From pi to 2 pi, sign ratio is in negative, again less than half. Only and only in this portion is sign ratio greater than half, and that means I have sin x is greater than half for x lying between what? I can say for all x or for all angles which are strictly greater than pi by 6 and strictly less than 5 pi by 6. It is these angles whose sign ratio is greater than half in this interval. Yes, I can only give surety of one interval. I cannot give surety about the rest of the subintervals in the domain, which is the collection of all real numbers. I only focused my attention on finding the angles in one interval of length 2 pi, and in that interval I am getting only these values as the angles which deliver me the sign ratio as greater than 1 by 2. And now the very algorithm says that once we have obtained the solution of the trigonometric inequality in one period, what you do is you add numbers of the form 2n pi to each of the solution of that interval and you obtain the entire solution set. So let us do that, because successfully we have obtained the solution in one period of the sine function. Now we need to obtain the solution in the entire domain of the sine function. And how do we do that? We know the solution in one interval is from pi by 6 to 5 pi by 6. What I do is, to every member of this interval from pi by 6 to 5 pi by 6, I add 2n pi, where n belongs to the collection of all integers. And what I will obtain is, I am going to obtain the entire solution set. So over here I can say, then sin x is greater than half for x strictly greater than pi by 6 plus 2n pi and strictly less than 5 pi by 6 plus 2n pi, n in the collection of all integers. Yes, this is nothing but an interval whose starting point is pi by 6 and ending point is 5 pi by 6. This interval's every member, when is added with 2n pi, gives rise to another interval which is pi by 6 plus 2n pi, comma 5 pi by 6 plus 2n pi. And because 2n pi is the period of the sine function, whatever is the behavior of the sine function in this interval, which is pi by 6 comma 5 pi by 6, the exact same behavior of the sine function will be portrayed in the interval pi by 6 plus 2n pi comma 5 pi by 6 plus 2n pi. And that is why I can guarantee that adding 2n pi is going to give me the entire solution set for this inequality. And that is why this is what happens to be your solution set. What is it? Each and every interval with starting point pi by 6 plus 2n pi and ending point 5 pi by 6 plus 2n pi is the very interval consisting of angles whose sine ratio is greater than half. And therefore, the entire solution set on the entire real line, which is the domain of the sine function, is what? You take the union of 2n pi plus pi by 6, comma 2n pi plus 5 pi by 6, this open interval where your n is belonging in the collection of all integers. That means you put n equals 1, you get 2 pi plus pi by 6, comma 2 pi plus 5 pi by 6. This is one interval consisting of angles whose sine ratio is greater than half. Then you put n equals 2, you get 4 pi plus pi by 6, comma 4 pi plus 5 pi by 6. This is the interval again consisting of angles whose sine ratio is greater than half. So this interval union, each and every interval obtained by plugging in specific values for n, all these intervals, when you take the union, give you the very set of the points or of the angles whose sine ratio is greater than half, and that is why this happens to be your solution for the inequality sin x greater than half. Make a note of this, understand this logically as to what is the algorithm and how did we bring into use the algorithm to find the exact solution of an inequality. Just understand that periodicity is coming into play over here and playing a major role in giving you the entire solution set. Spend some time and then we are going to start an entirely new article. And now that we have understood not just how to deal with trigonometric equations, but also how to deal with trigonometric inequalities, it's now time to move ahead and bring to use all of this. What do I mean by this is, now we will be heading towards the study of a very, very interesting section which is known as properties and solutions of a triangle. Yes, this is what we will be focusing on now. A triangle is going to come into picture and we will be learning to solve the triangle with the help of the properties of triangle. Yes, that's the entire motive. What did I say? I said triangles are going to come into picture and we will be learning to solve the triangle, find the solutions of the triangle by the use of properties or features of a triangle. That is what we are going to do. Isn't this a mind-boggling concept that we will be learning to solve a triangle? Now, what is the meaning of solving a triangle in itself is a question. Well, if I just draw a random triangle, you all know that any triangle is made up of three angles. Say angle A, angle B and angle C, right? Also, it is made up of three sides. Say this is the first side. Say this is the second side. And say this small c is the third side. That means a triangle ABC, if I say, triangle ABC is made up of 3 sides and 3 angles. That means there are 6 components of a triangle. 3 sides and 3 angles together make up the 6 components of a triangle. If you know all these 6 components, you will be able to draw the triangle. That means if you know all 6 components of a triangle, you know everything about a triangle. And that means you, in order to bring a triangle into existence, need these 6 components of a triangle. Solving a triangle means what? That means finding solutions of a triangle means what? Well, one fact is going to give the clear meaning of this notion. The fact is that out of the 6 components of a triangle, 3 components are independent and the rest 3 are dependent on these 3. Yes, that is what is true. Only if you are aware about the 3 components out of all these 6, if you are aware about any 3 components of a triangle, the rest 3 components can be found with the help of these 3 components. Yes, and that is how you successfully are able to obtain all the 6 components of a triangle and therefore bring triangle into picture. That is what is the meaning of solving a triangle. By the given 3 components, when you find the rest of the 3 components, you end up getting all the 6 components of the triangle, and these 6 components basically make the triangle. The process that you undergo while trying to find out the rest of the 3 components from the given 3 components, that process is what is called solving a triangle. And with the help of the given 3 components, when after undergoing the process of solving a triangle, you are able to obtain the rest of the 3 components of the triangle, these 3 components that you have obtained after solving the triangle with the help of the given 3 components are known as the solutions of the triangle. Yes, that is what is the meaning of solving a triangle and solutions of a triangle. And what are the tools which help you find the solution of a triangle? The tools which help you find the solution of a triangle are known as properties of a triangle. And so that is what is our venture of study now. The first thing that you should know is what is the meaning of solutions of a triangle. Because the entire task of ours would be solving a triangle. So, first of all, we should know what do I mean by solutions of a triangle or what do I mean by solving a triangle. So, given 3 components of a triangle, I'll just be denoting the triangle like this. So, given 3 components of a triangle, it's generally possible to find the rest of the 3 components of the same triangle. Right? And the process of obtaining them is called solving a triangle. And the 3 components obtained after solving the triangle are called solutions of a triangle. That is what is the meaning. Yes, the very process of solving a triangle is called this, and the three components which you obtain in the end of solving a triangle are known as solutions of a triangle. The question is, of course we know what is the meaning of solving a triangle, what is the meaning of obtaining solutions of a triangle, but the point is, how do we obtain the solutions? What is it that we should do so that we are able to solve the triangle? And that is what comes to be known as the properties of a triangle. It's the properties which come to rescue to basically help you in solving a triangle. The identities which establish relationship between all six components of a triangle are called properties of a triangle. We need these properties in order to solve our triangle. So that's what I'm going to write. Properties act as tools and help in solving a triangle. That means once we are aware about the very meaning of the six components of a triangle, wherein the three angles and the three sides together comprise to be the six components of a triangle. Once the meaning of this is understood, we should be very aware of our venture, which is to solve the triangle with the help of the properties. In the next lecture, I will be bringing to your very light the first tool, the first machinery, the first mechanism which is going to act as a property and help us in solving a triangle. We will be given three components, and the rest of the three components we will be finding by using that particular mechanism. So meet me in the next lecture. Till then, take care and study well.